Hi everyone. Today we are going to present on intelligent scheduling of Hubble space of telescope observations. So, SPIKE system, it is a general scheduling framework which is developed by the Space Telescope Science Institute of for NASA Hubble Space Telescope, which is called as SST. So the general approach for the SPIKE is motivated by constraint directed search. In this presentation, further we'll discuss on HST scheduling problem, theoretical and conceptual foundations of Spike. So Spike incorporates novel approaches, the both qualitative representation as well as propagation of hard statistics. The efficient scheduling is needed for space-based facilities due to the high cost, limited numbers, and unique scientific approach. So looking into the HST scheduling, this HST scheduling, it ranks the largest and the most complex scheduling problem. So it is launched in April 1990, and it provides the important capabilities for astronomical research as well as for wavelength coverage and angular resolution. So HST, it is actively engaged in full research program that it has produced many exciting results. So some of the scientific goals of this HST are like relative timing requirements, which are like minimum and maximum time separations and so on. So to provide the flexibility and like conditional and select flexibility. So this conditional exposures are contingent to the results that are obtained from this search HST scheduling. And moving further to see how we represent and how we use constraints and the preferences. So constraints, they convey two types of information to the scheduler. So they are like feasibility constraints as well as the preference constraints. So feasibility constraints, it specifies the conditions or the times when activities are scheduled, whereas the preference constraints, they specify the quality judgments on scheduling conditions. And so the feasibility constraints in this HST scheduling provides a minimum of 2 months between the observation and also the repeat observation of the same manner. And the preference constraints, they minimize the scattered light from the bright bulb and of the earth and maximize the chance of acquiring the stars. So ignoring the feasibility constraints, which will obviously lead to the unimplementable schedules, and disregarding the preference constraints lead to the unacceptable suboptimal schedules. So both the constraints, which are like preferable constraints as well as feasibility constraints, are important for HST scheduling. And coming to the consistency methods, so these consistency methods which will help to improve the search efficiency of these discrete CSPs. And some of the techniques that are useful in this speeding scheduling search is node consistency, arc consistency, and the path consistency. So node consistency is nothing but the removal from consideration of domain values that can be a part of the solution. Whereas the arc consistency, it is like the removal of values from the domains of the variables that satisfy the binary constraints. And the final one, which is the path consistency, it refers to the inference of additional constraints of the explicitly stated values. And coming to the computational aspects, so to implement the sustainability functions of the digital hardwares, so we need continuously monitor all the suitabilities and find the discrete values, whether it may be time, value, or both. So the Spike adopted discretion sustainability function values, which allows the sustainability functions to be represented as PCFs, which is called as piecewise constant functions. So these can be exposed as a time list, as a list of times and values, and those can be used for discretization sustainability. And in Spike, this fundamental discretization in time is avoided for two reasons. One is like it introduces the artificial time granularity into the problem, and other reason why we are avoiding this fundamental discretization in Spike is the many important constraints which yield the sustainability functions that have long intervals of or the constant values may discrete the functionality sometimes. So these are the computational aspects that are to be considered while we are doing HST scheduling and the Spike. And further slides will be continued by my teammate Pramin.
Hi, the next topic is about HST scheduling as a constraint satisfaction problem. To generate a scheduling problem into an CSP, we assign a variable to each activity to be scheduled and divide the scheduling time range from each action into intervals that correspond to the domain of the corresponding variables. A CSP, as it is commonly stated, considers only strict constraints and ignores preferences. We add these additional conditions that prefer to be maximized in the solution state to the problem. The challenge is to assign a constant set of values to all the variables so that no constant violation occurs. The next one is the Spike CSP toolkit. Now, there are three methods basically for this Spike CSP toolkit: inconsistent assignment and locked and ignore variables and removal and restoration of domain values. Coming to the first point, the variables may be assigned values that are inconsistent with other assigned values at any time. This is significant for two reasons. It enables information about constraint linkages among activities to be exploited during scheduling research and relaxed version of the problem. A variable can be forced to have a specific assigned value, then ignored, or it can be ignored if it does not have a assigned value. Any variable domains can be excluded from the problem, then restored at any time. When we talk about CSP, it represents the set of variables, constraints, and so on needed to represent a specific type of constraint satisfaction problem. And variables are assigned values, conflicts, preferences, and etc. are all represented. And the next one is time sampling. In HST scheduling, we generally choose two options that are initial implementation, progression to option. And the second one is specific constraints as we gained operational experiences. Some problems will have a natural time until in terms of which constraints are defined, ensuring that no sampling error occurs. As a part of this translation into CSP variable domain, the scheduling interval for an activity is decentralized. It can be divided into two parts. The entire interval is excluded. Feasible solution may be missed. The intervals are not excluded. Then we may find what appears to be feasible configuration, but may turn out into feasible when time is examined in detail. The next one is like scheduling search in Spike. There are mainly three types of techniques in this scheduling Spike. There are make a trial assessment and repair and deconflict. And in the first one, we discuss about activities of times based on heuristic that will be discussed further below. And the schedule will have a temporal or other constraint violations as well as resource capabilities. In the second repair part, we use heuristic repair techniques and try to eliminate the constraint violation until either a predetermined level of effort is expended or no conflict remain. The third one is deconflict. It basically we resolve the conflicts by removing any activities that violate constraint or by relaxing constraint until a feasible schedule is maintained. The next one is a trial assignment heuristics. After that, min conflict times are assigned with ties broken by maximum preferences derived from sustainability functions or earliest time. In some cases, the other heuristics are used such as the number of temporary related activities, task priorities, maximum sustainability, whether related tasks have assigned values, etc. It is worth noting that the spike trail assessment heuristics are quite simple and are based on simple measurements of constraint degree and constraints are connected. On this basis, several heuristics were identified. One of the most successful selects the most constraints activities to assign first. The next one is repair heuristics, how we can repair heuristics. Theoretical analysis and numerical experiments have both demonstrated that min conflicts can be very effective in repairing these heuristics. But we discovered that using a max conflict activity selection heuristic, which selects activities for repair that have most conflicts on their current assigned time, can result in even more improvement, or it tends to select for repair activities that violates the most important constraints. Both hill climbing and backtracking repair procedures have been attempted, but hill climbing has proven to be the most cost-effective on problems attempted thus far. One such repair heuristic is min conflict time selection, in which activities are moved to times where the number of conflicts is maximized. Here are the spike and next one is the spike and history science scheduling. Here we can see the diagram. There are a few processes like planning and pre-scheduling and scheduling and proposal and impact. When we discuss about preparation and observation proposals, An astronomer who intends to use HST must prepare an observing proposal that specifies the observation to be made. In long-term scheduling, because the HST scheduling problem spans such a wide range of timescales and tens of thousands of tasks, the two-tier scheduling approach was used. This spike has been specifically used in science operations since the launch of HST in early 1990s, and it was pre-launched readiness tests, and this is science operations. And the next one is transformation. Transformation performs several planning tasks, such as determining the order in which observations can be executed, and much better targets are visible and are in visible conditions, grouping observations to minimize overhead operations, selecting specific tasks, implementation scenarios, and supply values for instrumental settings. These are all types of transformations where heuristic functions are used. The next topics are covered by our teammate Sarupa.
Here is the long-term and scheduling and short-term scheduling. The main consequences of these computational accelerated estimations are stored in the circle records after an underlying pre-handling step registers outright time subordinate imperatives connected with the circle by circle target specifically. And momentary booking is completely consistently started with the runtime and SGS from the drawn out of plan and finishing with 7-day in length grouping of exercises known as schedule. Next. Here is the operational experience. The spike framework was first used to help HST booking for cycle.
Prabhu, I think you're on.
NASA laid out the plan for SVS perceptions. So the STL utilizes spike to check this timetable and to plan to got perceptions. It was accessible during weeks when time. And the cycle 0 close to the zone of 1999 and the cycle OV finished up in the November 1990. And the STSCLs and the POCC both screened the execution of the perceptions by observing outgoing transmission by in the next slide. Sorry. And the applications of spike and to the other astronomical scheduling problems, the spike has been adjusted to deal with the wide scope of cosmic planning issues. And the spike was as recently expressed was planned so that the assignments and the imperatives can be expressed without influencing the fundamental structure. In the next slide is the adaptations of spike to various astronomical scheduling problems. The main prototypes were developed in 1988, and it was a short-term scheduling to scheduling with the night. And the telescopes includes ESO and the observations and the CFHT, as we have digital automatic photometric telescope. And the post-processor that examines the short-term schedules offer the opportunities to extend task durations, and as a result, make use of many remaining small gaps in the schedule to improve efficiency. And here is the next slide, please. Here's a figure. Sorry, and the Spike CEM user interface displays as an Astro D long-term schedule in the figure. It is shown in the figure. It depicts the portion of the high resolution PostScript plot output from the Astro D Spike. And the next slide, please. This is an example of the Spike output of short-term scheduling of astronomical observations. Shown as it is a 24-hour portion for the 7-day schedule. You can see the 7-day schedule and the 24-hour portion. And the next slide is the conclusion part. Here we go, the NASA schedules Hubble Space Telescope, and spike adaptability has been demonstrated by adapting it for the variety of other spacecraft missions. And then its references. Here are the few references that we have taken for this presentation, and thank you.